Hi and Assalamualaikum warahmatullahi wabarakatuh. Today, our group will be presenting one of the subtopic in Calculus 1, application of differentiation. Now, let's meet our fantastic group members, starting from Fatina Bila, Nur Amina Jiha, Balkish, and Nur Nadra. So, let's get started.
Okay, so let's start with the meaning of differentiation. So, what is differentiation? Differentiation is a process of finding derivative or rate of change of a function to determine the maximum and minimum values of particular functions. To solve differentiation problem, there are three techniques that we can apply, which is derivative of sum and difference, derivative of a product function, which is called the product rule, and derivative of rational functions, which is called the quotient rule. The rate of function is defined as dy over dx of x and y. Next, what is related rates? Related rates is a method used in calculus to find the rate at which one quantity changes in relation to another quantity. This is particularly useful when dealing with problems where multiple variables are interconnected and changing with respect to time. So, why do we use related rates? Let me give you a situation. Imagine you are watching a balloon being inflated. The volume of the balloon increases, which in turn changes its radius. If you know how fast the balloon is increasing, you might want to find out how fast the radius is changing at a specific moment. Related rates help solve such problems by connecting the rates of change of different variables.
Assalamualaikum everyone. So today I want to explain my part in this group assessment. So my part is question number 1. In this question there is a statement given. A watermelon initial weighs 5 kg. After being left out, it must decrease over time according to function mt equals to 5 exponent power of negative 0.1 t, where mt is the mass in kilogram and t is the time in days. Since the watermelon being left out, assume the watermelon is spherical and density pt and radius rt change over time as well. The density of watermelon change accordingly to the function pt equals to 0.001 exponent power of negative 0.05 t. Given the initial radius of the watermelon is 15 cm. First question asks about find rate of change of the mass at t equals to 3 days. So the first step, we need to take out the function given from the statement, which is 5 exponent power of negative 0.1 t, and we need to differentiate this function, and after that we get the answer negative 0.5 exponent power of negative 0.1 t. And because of the question asks about t equals to 3 days, so we need to substitute the value of t equals to 3. So it will become like this: negative 0.5 exponent power of negative 0.1 multiply with 3, and we got the final answer, negative 0.3704 kilogram per day.
So next is question number 2. We need to find time of which the rate of change is negative 0.25 kilograms per day. So the rate of change is negative 0.25, and we will take the previous function, which is negative 0.5 exponent power of negative 0.1 t, and equals with the rate of change, which is negative 0.25, and we will divide the negative 0.25 with negative 0.5, and we will get exponent power of negative 0.1t equals to negative 0.5. And we need to move the exponent to the right side, and we will get ln. So we get negative 0.01t equals to ln 0.5. And we need to find the t, so we will divide ln 0.5 with negative 0.1, and we will get 6.931 day for the time. So question number 3 is to find the acceleration of mass loss at t equals to 5. So we need to find the mass loss of the watermelon after 5 days. Since we know the first derivative is negative 0.5 exponent power of negative 0.1t, so we can find the second derivative, which is 0.05 exponent power of negative 0.1t. And from the second derivative, we can find the mass loss of the watermelon after 5 days. So we will just take the second derivative, which is 0.05 exponent power of negative 0.1t, and substitute the 5 into the t, and we will get 0.0303 kilograms per day. Gitu je dah.
So let's move on to the question 4. Find the radius of watermelon at 3 equals to 3 days. So we know that the formula of mass is equal to density times volume. So using all the information that we have the equation mt equals to pt times 4 over 3 pi rt cube. So we need to find the mass and density of the watermelon at day 3. So we substitute the value of 3 into the equation 5 exponent negative 0.1t, and then we got 3.704 kilogram for the mass. So next, for the density, we substitute into the equation 0.001 exponent negative 0.053. So we got the density is 0.001 exponent negative 0.15. So after we got the value of mass and the value of density after 3 days, we just substitute that value into the formula of mass that we just got. So now we got the formula is 3.704 equals to 0.001 exponent negative 0.15 times 4 over 3 pi rt cube. So we know that the t is now equals to 3 days, so r3 cube equals to 3.704 over 0.001 exponent negative 0.15 times 4 over 3 pi. After that, we just solve the equation and we got the answer for the radius of the watermelon at t equals to 3 days is 10.0904 cm. So the summary, differentiation provides essential tool for analyzing and solving real-world problems, making it invaluable across numerous topics. Therefore, identifying the correct formula and mastering the first and second derivatives will lead to a solid answer for all of our questions. Thank you.